So in this question, we have an AC generator. As you can see, the graph shows a potential between point X and Y, which is plotted against the positive value of a potential indicate X is more positive than Y. Like if X is positive and Y is negative, means what should be the direction of the current? Because in the question they mention X is more positive than negative. So direction of the current is like this, conventional current from positive to negative. So which direction the current will move means the current will move in this way. Okay. That's how the current should move according to in the question what they specify that X is more positive than Y. So if X is more positive than Y, it means that how the current we should move the conventional current from positive to negative, the movement of the current. Or like if I use a complete circuit, so this is negative, this one is representing positive. So this is representing negative, this is representing positive. So the direction of the current from conventional current from positive to negative. So if we show the directions, I complete this. So current will go like this. Means it should go like this. If X is positive and Y is negative, that is a complete cycle of one current. Is it clear? The cycle of the current? No, between X and Y is not the fuse. Between X and Y is actually, it's not a fuse, it's a fixed resistor is there. I drew a line, so maybe it looks like a fuse, but between X and Y, this is not the fuse. This is a fixed resistor, which has a potential, a voltage is there, and they mention X is more positive than Y. So this is how the current looks like if X is more positive than Y, okay? That is the first thing. Now, if we observe this, like according to a question, X is more positive than Y. Now, when we observe the motion of this, the movement of the wire, and we work out the direction of the induced current. So this is negative, this is positive, okay? But if we work out, so according to this direction, the current should be, the direction of a current should be from Y, X to Y. But when it is moving at this position, when it is moving, like I call this as a side AB, I call this as a side A, B, C, D, okay? And when I apply the right hand rule, the Fleming's right hand rule, so my index finger is pointing towards south, my second thumb is pointing up, down in for this one. So what is the direction of the induced current? The direction of induced current is from C to D. That's how the current will produce. If you apply the right hand rule, your index finger is pointing towards south, your thumb is pointing downward. Your right hand, when you apply, your index finger is pointing towards south. Your index finger is pointing towards south, your second finger, your thumb pointing downward. Your second finger shows the direction of the current. So in that case, the direction of a current is from C to D, or A to B, B to C, and then C to D. So means the direction of the current is like this. So what it shows, according to this position, X should be positive, Y should be negative. But when the coil is rotating in this manner, the direction of the current is opposite to the original direction. Because the original direction of the current should be in this way. But when the coil is at this position, the direction of the current is in opposite way. So means what is this voltage? This is a negative voltage. Because when X is positive, Y is negative, that voltage we call positive. Like example, we say plus 2 volts. But now what happened as a direction of the current, is now from Y to X. So it means Y is positive and X is negative. So what is this voltage? This will be minus 2 volts. So mean this position represent an opposite voltage or a minus 2 volts. So which one on the graph shows a minus 2 volts, or which position of the graph shows a minus 2 volts or opposite direction? So this is the same thing because it is representing the same idea. So this is, so C should be the right answer for this. Is it clear? Should I repeat? Okay, sure, I'll repeat. Look, you have this AC generator and the voltage is positive. The voltage is considered as positive when X is plus and Y is minus, and the direction of a current is from X to Y. Okay. So if the direction of the current is from X to Y, we call that as a positive voltage. And if the direction of a current is from Y to X, we'll call that as a negative voltage. Now, when you check the motion of the wire, so current from X to Y will consider as a positive. But if the current is from Y to X, we'll consider as negative. Because in the question, they specify that 2 points are there, X is more positive than Y, so X should be considered as positive, Y is negative. If the current is in opposite direction, then we call that as an opposite or a negative voltage. Now, when we work out the direction of the induced current, which direction the current produces, this side is going down, this side is going down, and this side is going up. So when we apply the right hand rule, your index finger is pointing towards south, your second finger is, your thumb is pointing downward. So which direction your second finger point? In this way. So means the direction of the current is like this. So if the direction of the current is like this, so it means the current is now moving from Y to X. So if the current moves from Y to X, it means that current should be considered, or a potential should be negative voltage. So on our graph, if I say mark the position on the graph where we'll have this. So what you will mark? You will mark it here or you'll mark it here. How do we know the direction of a magnetic field? As you can see, a magnet is there. So for a magnet, the direction of a magnetic field is from north to south. So your index finger point from towards the south, your thumb point downward, and that's how you got the direction of the current. So the direction of the current is actually from Y to X. So it means it is an opposite negative voltage or a negative current. So that's why on the graph, we want to label the negative voltage. So if you want to label, because the point P is a negative voltage or the opposite voltage. So which one is representing an opposite voltage? So this same figure is actually representing an opposite voltage. Because if X is positive, Y is negative, current should move in this way. But according to this position, the current is moving in opposite direction. So it means this is a negative voltage. So here, this position P is actually the same figure, or it matches with option C. As you can see, this one is on the right and the other one is on the left hand side. Is it clear? So same way, you can also consider like if X is X should be positive, Y should be negative. So if X is positive, Y is negative, what should be the direction of the current? According to this X positive, Y negative, the actual direction of a current should be like this. Which region of an electromagnet spectrum detects the fake banknote because the bank ink is having a trace of UV powder, UV trace? Since it is AC, that's why the current reverses after 180. Yes, that's right. It's an AC generator. The direction of the current reverses after every 180 degree rotation. Like if the previous question first, the current is, let's say it's like this. The next moment, the direction of the current will be reversed. It will move in this way. So which you have to learn the uses of these radiation. The fake banknote for recognizing a trace of UV powder is there. So that's why ultraviolet radiation. This is actually a use of the ultraviolet radiation for killing microbes as well as used in the banknotes. The angle between the rod and the vertical is increased. State whether the force F needed to hold the rod stationary must increase, decrease, or stays the same. Where is that rod? This is only one part of the question. Send the remaining of this question. I will discuss this. So next we have a diode is there and a resistors are connected across a DC supply. The terminal X is initially positive and it has a maximum value. The potential between X and Y is adjusted so that it changes. As you can see, first X is positive, then X will become opposite. Like X will become, as you can see, we use a negative axis of the graph. So first when X is positive, will the diode conduct? Any charges will flow through a diode? Yes or no? No, the diode will not conduct because the current can only, for a diode, the current can enter only from the side of the plane, not from the pose. So diode will not conduct. So yeah, it is a reverse bias. So means till this part, the diode will not conduct. So means we'll have a zero current. So as you can clearly see, only one of the options we have a zero current here. And then when it is reversed, when the X is reversed, like now X is negative and Y is positive, so diode will conduct. So the diode start to conduct or current start to flow. So initially the diode won't conduct. That's why the current should be zero. So even from the first part, I can indicate or identify that there will be no current in the circuit. As a diode, in the forward bias, the diode allow the charges to flow. Or the reverse bias, it block. The graph part, like how the graph work, this graph is simple, like what it shows. See, when we have X is positive and Y is negative, this is a part of the graph in which X is positive, Y is negative. And then when we use a negative axis of the graph, what does it mean? It means now Y is positive and X is negative. And we are increasing the voltage. So first, when X is positive and Y is negative, and we are decreasing the voltage. Like first it is 3, then we did it 2, then we did 1. But because the diode is in a reverse bias condition, so it won't conduct electricity at all. No charges will be able to flow out. So it means the current which is passing through a diode will be zero. No, this is the potential across X and Y. This is the value, the voltage between X and Y. It's not like X will be positive voltage concept is not like this. When I say the voltage is 3 volt, it means X is positive, Y is negative. But it does the potential across the voltage difference between X and Y is 3 volts. So first we started with 3 volt. Can a diode conduct at this voltage? No, it won't conduct. So the diode won't conduct at this voltage. Then if I reduce this same voltage, I did not change the polarity, but if I reduce the voltage to 2 volts, can a diode conduct? No, it won't conduct. Because the voltage, even though voltage is there, but that is not the polarity, the diode cannot conduct in that. If the voltage is zero, that again the diode will not conduct. Then we change the polarity. Now X is positive, Y is positive, X is negative, and it's -1 volt. Why -1 volt means the direction has reversed. So direction has reversed, now the diode will start to conduct. So that's why the graph for a diode, first it won't conduct and then it will start to conduct. That's why the shape of the graph, first it was a zero current and then the current start to flow. How do that X is positive and Y? They mention in the question that X is positive and Y is negative. That is mentioned in the question. That initially the terminal X is positive, this they mention in the question. And it has a max. So if X is positive, Y is negative. Here means X is positive and here means X is negative. So if X is positive, the diode won't conduct at all. And when Y is positive, the diode will conduct. So actually, you don't have to bother the whole question. Only this part will give, if X is positive, the irrespective, even if I apply 100, like if I apply a high volt, that diode should not conduct. But there is a voltage even in a reverse bias that a diode just, that is called an avalanche. When a diode even in a reverse bias start to conduct, but that's a very high voltage that can damage the diode. Why in the positive case the diode conduct? Because the conventional current, when X is positive, Y is negative, the diode block the current. Because a diode is a rectifier, it only allows the current or the charges to move in one way. So when this Y is positive, X is negative, the diode start to conduct. So one way it allow, other way it blocks. A wind turbine is 30% efficient, means 30% of the total energy converted into a useful output. The output is 2.5 megawatt. What is the power input? So efficiency is equals to useful output divided by total input times 100. All the units are in megawatt. Look, all the units are in megawatt, so I don't have to convert the unit. It's fine. I can use 2.5 here because all are answered in megawatt. What is the efficiency? 30% efficient. So the efficiency is 30. Output is how much? It's 2.5. Input we don't know. It's unknown. We call that as X into 100. If I need X, so X will be equals to 2.5 multiplied by 100 divided by 30. So 2.5 times 100 and divided by 30. So we got 8.33. And the unit, because I did not, all the units are in megawatt, so that's why I did not convert the unit. So 8.3 megawatt will be the answer. Yeah, if you solve other way, you will also get the same answer. Oh, it's a math, like the same thing. You're saying move 100 to other side. This is 30 divided by 100 is equals to 2.5 divided by X. 30 divided by 100 is 0.3. So 0.3 is equals to 2.5 over X. X is divided, other side multiply. So X is equals to 2.5 divided by 0.3. Again, you will get the same answer, 8.3. A bar of a metal, which is a good thermal conductor, is heated at the one end. So you have a metal bar, a lattice of a positive ions and the delocalized electrons. How the energy transfer, two things happen. One is by the lattice vibration. The particles are there, they're colliding and transferring energy. Another one is the movement of electron. When these electrons move, they collide with the lattice as well, or they collide with each other and transfer the thermal energy. Because in a conduction, what will happen? It's the thermal energy transferred by the vibration of the lattice as well as the movement of electron. What is the main method of transfer of a thermal energy along the bar? So what is the main method? A lattice vibration, movement of atoms. Atom does not move in a bar magnet. Transfer by electron, vibration of atoms of the metal bar. So these two are actually like vibration of the lattice there, but the main thing what happen is electron actually move from one place to another. Electron actually move from one place to another and they carry the energy. So the movement of the electron in the structure and these electrons collide with the lattice, they transfer their energy. So maximum amount of energy is transferred by this way. That is even a 3-mark question they ask about explain the conduction, how conduction happen. So conduction happen through the in the metal, how conduction happen by a lattice vibration and the transfer of electron from one place to another or transfer by the electrons. Is it clear? So A is not correct. It's mainly like electron move from one end, collide with the lattice and transfer energy. And the second thing is also a vibration of the lattice. But main method is because of the movement of these electrons. A TV station transmits a signal to a television dish. A television is switched on by a remote control. Which electromagnetic wave in these actions have the longest wavelength? So you have to recall like the electromagnetic spectrum. Longest wavelength, radio is having the longest wavelength. But we don't have here, this is a micro one, like radio, micro, infra, visible, ultraviolet, X-rays, and gamma. So radio is having the longest, like in this order, the wavelength increases. So this is the microwave is there. This is a visible light is there, and here is the infrared. So we have this IR radiation or infrared radiation. And then we have a microwave. So which one is having the shortest? So microwave, longest, I mean, the microwave. Because the electromagnetic spectrum, after radio, we have micro, then infra. So order of the spectrum, you have to learn. Is it clear? Several scientists are working in a lab and are experimenting with the source emit ionizing radiation. Each scientist is given a list of safety rules. 3 of the rules are shown. Keep at least 2 meters away from the other people. Do not stay longer than 4 hours per day in a lab and stay behind the lead line screen. Which safety rules are protecting against the effect of these ionizing radiation? No, the previous answer was a microwave because the question was which is having the longest wavelength. So microwave is having longer than infra and visible. If it was a radio, then that will be the answer. Keep at least minimum 2 meter. Like even if you are using in the lab, if you are using alpha, what is the range of alpha? What is the range of alpha? Few centimeter. So if you have a few centimeter distance from the alpha, because ionizing radiation means they're talking about all together alpha, beta, and gamma. So standing too far, like example, 2 meter away from a, and 3 rules is at least keep 2 meter away from other people, which are emitting out the ray, and each scientist is given a list of safety precautions and do not stay longer. If you're exposed, like then 4 hours per day in the lab, this is representing the exposure time. Like if you minimize exposure time, that will reduce the effect on the health. Like example, if a person is exposed to a radiation for a longer duration of a time, yes, he will may develop a cancer. So Exposure time should be minimized and stay behind the lead line screen. Lead is a material which can stop. So means any option with 3 should be the right. And minimum distance, it's not like minimum at least 2 meters away from the other people. Is it clear, this one?
Yes, sir.
We don't need social distancing here in, look, when you have a radioactive source, look, when you are using a radioactive source, use forceps. We, instead of saying keep away from like 2 meters away from the other people, it's not about the distance. So it's about like using a forceps to hold the source. Exposure time should be minimized and you should use a lead line. So in that case, D. The next is determine the ratio of a potential between R2 and R3. R1 and R2 are connected in parallel. So what is their, they are all identical. So if two identical resistors are connected in parallel, so what should be the combined resistance? The combined resistance will be half. Like if, because it is a product divided by sum. So when you simplify R square over 2R, so it means it will be R by 2. So whenever two resistors are connected in parallel, it will become half. So mean this two combined will be R by 2. And this resistance is still R. So if I have two resistors, like these two resistors combined, their resistance is half. And this resistance is R. And I have a supply. So which side I will have more voltage? Like if I compare the voltage, because the ratio of the resistance and the ratio of the voltage will be same. So this will be V by like, or if I simplify this ratio, I can also say this will be R and this will be 2R. Like the ratio between R by 2 is to R means 1 by 2 is to 1. Or if I further simplify, I can say it is 1 is to 2. So that's why the ratio is 1 is to 2. Yeah, we represent, ratio should always be a whole number. Whenever we represent ratio, it's not in fraction, it should be a whole number. Like if I'm getting a ratio 1, if I'm getting a ratio 1 by 3 is to 1, so I can say the ratio should be 1 is to 3. Because ratio we represent in a whole number rather than a fraction. Fission and fusion are the two types of a nuclear process. How does the total mass, how the total mass will change in even in a nuclear fission or a fusion? Look, the mass has converted into energy. That's how it produces energy. Like we have a matter, two nuclei are there. Even in a nuclear fusion, lighter nuclei join to form heavy. Plus, what happened to the remaining mass? The remaining mass is converted into energy. So if I compare the total mass, like if I say this is 2 kilogram, example, this is just an example. This is also 2 kilogram. So this mass will be higher. It will be like maybe 3.5 kilogram. But what happened to the remaining mass? What happened to the remaining 0.5 kilogram? That remaining 0.5 will be converted into energy. That's how the nuclear reaction produces energy, the mass converted into energy. Same thing in a nuclear fission. When we have a heavy nucleus, let's say you have a 5 kilogram, and you break down this heavy nucleus into a lighter. So the lighter nuclei, maybe this is 2 kilogram, example, this is 2.5 kilogram. So what happened to the remaining 0.5 kilogram? Remaining 0.5 kilogram will convert into energy. So even in a nuclear fusion and a nuclear fission, the total mass will decrease. And why the total mass will decrease? Because that remaining mass converted into energy, and that is what is released. So if we compare the total mass of a fission product or a fusion product, it will always decrease. And what happened to that mass? It has converted into energy. So if a fission happen in a nuclear fission, we call heavy nucleus break down into a lighter. So if this is, let's say, 5 kilogram, I'm just giving an example with a simple number. So when it break down into lighter, this is 2 kilogram. This is also 2 kilograms. So what happened to remaining 1 kilogram? That remaining 1 kilogram converted into energy. Same thing happened in a fusion. In a fusion, let's say you have two atoms which are having a mass of 2 kilogram. When they fuse together, they will produce a heavy nucleus. That heavy nucleus will have a mass of 3.5. But what happened to the remaining 0.5 mass? The remaining 0.5 kilogram has converted into energy. So when we compare the total mass of the reactant and the product in a fission or in a fusion, both cases the total mass will decrease because the remaining of the mass converted into energy. So they ask us how the total mass of a nuclide produced compared with the total mass of the original in nuclear fission or in nuclear fusion. In both cases, it will decrease because when it decreases, the remaining mass is converted into energy. The question was about the total mass. Is it clear, this one? That's also the Einstein concept of E is equals to mc square, that the matter can convert into energy and energy can convert into a matter. Yes, same concept, relativity. Yeah, that's right. So the question was a total mass, not individual atoms. The drag force on a car increases with speed. At 20 meters per second, the drag force was 400. The mass of the car is 1200. The driving force is 700. Which statement about the acceleration of a car at 20 meters per second is correct? So there's a car which is having a mass of 1200 kg. The driving force, the force which is driving the car, is 700 newtons. And the drag force, the force which is opposing the car, is 400 newtons. And at this moment, what is the speed of the car? The speed of the car is at 20 meters per second. So this is moving at a speed of 20 meters per second. So what about the resultant force here? Resultant force will be 300 newtons because 700 Newton forward, 400 Newton backward. So resultant force will be 300. And what about the acceleration of this car? So acceleration is a resultant force divided by mass. So resultant force is 300 and the mass is 1200. So 300 divided by 1200. So the acceleration is 0.25 meters per second square at this moment. Okay. Now, what will happen as the car accelerate? So this is 1200 kg and the car, in the question, the drag force of a car increases with the speed. So, and the mass of a car is 1200 kg and the result driving force is 700 constant. So what happened to the acceleration? We got acceleration as 0.25. Because the car is accelerating, the driving force remains 700. As this car is accelerating, because it has an acceleration of 0.25. So if this car accelerates, what happened to the drag force? The force which is opposing the motion. So the force which is opposing the motion will increase. Why it will increase? Because when we calculate the acceleration, the car is having an acceleration of a 0.25. So whenever anything is having an acceleration, so means the force which opposes the motion or the drag force, the speed increases, so the drag force will also increase. If the drag force increases, what happened to the resultant force on the car? The resultant force of the car will decrease because the resultant force on the car is a driving force minus the friction force. The driving force is not changing, the friction is increasing, so the resultant force will decrease. If the resultant force will decrease, what happened to the acceleration of the car? The acceleration of the car should also decrease. So it has an acceleration, right now it has an acceleration of 0.25, but because the car is still accelerating, so the speed of the car increases, as the drag force will also increase, so the acceleration and the resultant force should decrease. So A should be the right answer. Is it clear discussion? Yes, I will repeat. Look, you have a car which is having a constant driving force of 700 Newton and which has a drag force, the force which is opposing the motion, 400 Newton. The mass of the car is 1200 kg. So when you calculate the acceleration right now, acceleration will be 300, the resultant force, divided by 1200, the mass. So acceleration is 0.25. Because this car is accelerating, it is having an acceleration. So what should happen to the drag force? The drag force should also increase. So next moment for the same car, what will happen to the next moment? The driving force is 700 Newton. And the drag force, it was originally 4, it should increase. Why? Because the car is accelerating. So drag force might be 500 Newton. So what happened to the resultant force? The resultant force will decrease. It will be 200 Newton. So when you find the resultant force will be 200 Newton. So what happened to the acceleration of the car? The acceleration of the car will decrease because the resultant force has decreased. The forward force or the driving force is not changing, but the backward force is increasing. So the resultant force decrease. As the resultant force decreases, so the acceleration should also decrease. Is it clear? The question is alpha particles. This is a gold foil experiment. Most of alpha particle passes through the foil. Most of alpha particle are virtually undeflected, and small fraction of alpha particle, large angles like changes, and a small fraction of alpha particle bounce back. So some bounce back, some changes the direction, most of them passes through. Which conclusion does not follow these observations? Most of the matter, most mass of a gold atom is in the nucleus. That's right. Most part of atom is empty. That's also right. Nucleus contain proton and neutron. That is not a conclusion. What was a conclusion? That nucleus contain mass, nucleus contain charge, and the nucleus does not have, or a size of a nucleus is very small compared to an atom. So these are the observation conclusions. So it specifically, Rutherford did not classify that the nucleus has proton and neutron. Nucleus does contain proton and neutron, but that is not by the Rutherford experiment. And the nucleus must be charged, that's also right. Because the first two conclusions are from this result. And the last one is from this one.